Hi students, in this video we're going to talk about solving multiple angle equations. It's a lot like the type of equations that you already know how to solve, but you'll see that there's just one more step at the end. So a multiple angle equation is one where you have sine of k times u or cosine of k times u. The point is that instead of just having a variable, you have your variable times a number. So for example, you might have sine of 3x or cosine of negative 2x. And we want to solve for x, but it's attached to this other constant, this negative 2 or this 3. So our strategy is to first solve for k times u. So first solve for the 3x, or first solve for the negative 2x. And then divide everything by k. So really, just one more step. At the end, we divide by whatever this constant was that was multiplying x. Now, the reason that we have to do this is because well, we're sort of treating 3x as our variable the whole way through if that's what we solve for. And so if I want to actually get at x, then I need to divide by 3. So let's do a quick example. If I have 2 cosine 3t minus 1, and I want to solve for t, my first step is to treat the 3t as my variable. Solve for 3t first. So I do what I always do. I'll first bring over this 1, and then I'll divide everything by 2. So I'll get cosine of 3t equals a half. And now I remember that cosine of some, so I'm trying to figure out what angle, which is going to be 3t, has cosine equal to a half. So if I'm in the first quadrant, that happens for, well, that'll be pi over 3. Cosine is also positive in quadrant 4, and so my other answer is 5 pi over 3. So that tells me that my angle, which is 3t, equals pi over 3 plus some multiple of 2 pi for the general solution, or 5 pi over 3 plus a multiple of 2 pi. But now I have to do this second step, divide everything through by this constant. So I divide by 3 to now get t by itself. So I get t equals pi over 9, because when I divide pi over 3 by 3, I get pi over 9, plus n times 2 pi divided by 3. I have to divide this part by 3 as well, because this function has a different period than the function just cosine of t. And my second solution will be 5 pi over 9 when I divide this by 3, plus n times 2 pi divided by 3. So that's my answer. Same as usual, with one more step, dividing by 3. Let's do one more example. In this example, I want to solve 3 tan of x over 2 plus 3 equals 0. So my strategy is to first solve for this piece, solve for x over 2. So treat this as the variable and solve for it. So I want to know what angle satisfies this equation. So first step, same as before, we'll bring the 3 over. And then divide through by 3. So now I'm treating this as my variable. I want to know what angle has tangent equal to -1. So tangent is negative in quadrant 2 and quadrant 3. When we're in quadrant 1, the angle pi over 4 has tan pi over 4 equal to 1. So in order to make it negative, we need to push that into quadrant 2. So one solution is 3 pi over 4 plus multiples of pi. Another solution would be our, tan is negative, not in quadrant 3, but in quadrant 4. So our other solution would be 7 pi over 4 plus multiples of pi. But this isn't our answer, this is what x over 2 equals. So now to get x, my k here equals 1/2. So if I divide everything through by 1/2, that's the same as multiplying everything through by 2. So if that's confusing, I'll say it one more time, pause it and think about it. In order to get x by itself, I need to multiply by 2 on both sides of this equation. Multiplying by 2 is the same as dividing by 1/2. So my final answer is x equals 3 pi over 2 plus 2 times n times pi, and 7 pi over 2 plus 2 times n times pi. And that's all there is to it. So I hope that this video was illuminating and gave you some strategies for solving these new types of equations. Good luck, and we'll practice in class.